Dear students, already we have discussed about functional dependencies, multi-value dependencies and joint dependencies. Along with that, we have discussed different normal forms like first normal form, second normal form, third normal form, DKNF, fourth normal form and fifth normal form. So, under this topic, now we are going to see some other dependencies and normal forms today. First we will see what is meant by inclusion dependencies. In order to define inclusion dependency, we have taken the two relation schemas R and S. The attributes in R is called as X. The sets of attributes in S is called as Y. Okay, between two sets of attributes, that is X and Y, specify the constraint that at any specific time when R is a relation state of R and S a relation state of S, we must have relation state means we know the data present in that things, particular consistent state. Must have pi that X of, that is R of R, that should be a, there is pi Y S of S, that should be a subset of pi X R of R. Okay, this is the thing, this is called as inclusion dependency. That is Y is included in X, that is the meaning. So, what is the thing means? The subset relationship does not necessarily have to be a proper subset. It is not a proper subset. Proper subset means it will be there only this symbol. There is that this equivalent symbol also there. So, it is not necessarily it is a proper subset. The sets of attribute on which the inclusion dependency is specified, X of R and Y of S must have the same number of attributes. Number of attributes in X set and number of attributes in S set Y set should be same, and also the domains of each pair of corresponding attributes should be compatible. The attributes, the domain of attributes should be compatible. That is other conditions. First, that subset relationship should not be a proper subset. Second thing is number of attributes in X and R, Y should be same, and the domain of attributes between the pairs should be compatible. Okay, so the objective of inclusion dependency is to formalize two types of interrelational constraints which cannot be expressed using functional dependencies and multi-value dependencies. So, this is the main aim of this objective of functional inclusion dependency. One is referential integrity constraints. Okay, next one is class subclass relationship. Class subclass relationships already you know we are going to use in inheritance concept. Okay, so that for representing that we are going for this inclusion dependencies. So, in the inclusion dependency inference rules are, the first one, inclusion dependency inference rule 1 is called a reflexivity, that is R dot X is that less than R dot X. Then the inclusion dependency inference rule 2 is attribute correspondence if R dot X is less than S dot Y, where X is equal to A1, A2, etc. A1, Y is equal to B1, B2, B3, etc. Bn, and AI corresponds to Bi, then R dot AI should be less than S dot Bi for all I should be less than or equal to N, should lies between 1 and N, I value should lies between 1 and N. Okay, this is the condition. Then what is that inclusion dependency inference rule 3 is transitivity rule. That is, if R dot X is less than S dot Y and S dot Y is less than T dot Z, then R dot X is less than T dot Z. This transitivity, this is called as transitivity rule. Okay, so these things you should know for inclusion dependency. Then next we are going to define about functional dependencies based on arithmetic functions and procedures. So, arithmetic functions also we can use in that function dependencies. So, for example, we will take one as long as a unique value of Y is associated with X, that we are going to give X defines Y. We can still consider that the functional dependency X defines Y exists. For example, we will take one relation called order line. It contains the attributes order number, item number, quantity, unit price, extended price, discounted price. Okay. So here each tuple represents an item from an order with a particular quantity and the price per unit for that item. So here if we know the quantity and unit price, we can find out the extended price. How we can find out the extended price? With the formula of quantity into unit price, using that. So hence there is a unique value for extended price for every pair, thus conforms to the definition of functional dependency. Okay, that function we have viewed, that also we can use it in this. Then procedures, there may be a procedure that takes into account the quantity discounts, the type of item and so on, and computes a discounted price for the total quantity ordered for that item. I think already you people have studied about the functions and procedures and differences. Okay, so how we can represent means odd item number, quantity, unit price defines discounted price, or item number, quantity and extended price defines discounted price. Okay, so this we can represent with the procedures. So this is a thing about functional dependencies based on arithmetic functions, and this is procedures. And next one is the domain key normal form, DKNF. Okay, so this is one type of normal form. A relation schema is said to be in domain key normal form if all constraints and dependencies that should hold on a valid relation states can be enforced simply by enforcing the domain constraints and key constraints on the relation. Okay, so it has to satisfy all those things in any relation, valid relation state should satisfy that all the domain constraints and key constraints of the relation. That is why it is called as domain constraint, it is satisfying, and key constraints. So it is called as domain key normal form. So okay, the idea is to specify ultimate normal form, okay, that takes into account all possible types of dependencies and constraints. Okay, so from name you have to remember satisfies domain constraints and as well as key constraints on the relation at any valid relation state. Okay, so the domain key normal form DKNF for a relation in domain key normal form, it becomes very straightforward to enforce all database constraints by simply checking that each attribute value in a tuple is of appropriate domain. Each attribute should be in a appropriate domain, and that every key constraint is enforced. In key constraints we have studied the different types of key constraints, primary key, then foreign key, and then unique key. Okay, everything we have studied. That key constraint, every key constraint should be satisfied, as well as that each and every attribute should have a appropriate domain. Okay, that should be satisfied. That is the thing. So the practical utility of domain key normal form is limited because it has to satisfy all the domain key domain of an attributes and as well as key constraints. Okay, every key constraint in that relation. Okay, that is why the practical utility of domain key normal form is limited. So that is all about this normalization unit. So in this unit we have studied the functional dependency and the different types of normal forms and the different types of algorithms, inference rules, equivalence and minimal cover and so on. So and along with that go through the problems to find out closure and as well as minimal cover and the relation is in which normal form and so on.